quadratic functions in standard form. So let's think about first. This looks like having an earthquake. Okay. Let's think about the parent function of a quadratic. I'm just going to leave it up on the board so you don't have to flip back and forth. Where's the vertex of a quadratic? 0, 0. And then what's the pattern for a quadratic? Where do I go next to form that parabola? It's a U shape. Where do I go next from the vertex? Over 1 and up 1 in both directions, because 1 squared is 1. So y equals x squared. 1, 1 is your first movement. Where do I go next? From the vertex, I go over 2. Nope. What's 2 squared? So over 2, I'm going to go up 4. So I'm just going to write down 2 comma 4 over here. And then what is over 3? So when I go over 3, what's 3 squared? 9. So up 9 is way up here. So 3 comma 9. I'm squaring the x value. So here's my poorly drawn parabola, but there we go. 1, 1, 2, 4, 3, 9. You've got to have these 3 kind of moves memorized. This is just a transformation then. So now I'm just doing left, right, up, down, flip, or shift. So you're practicing your transformation rules this week. So what does the +4 do? Is that left or right? Left. So I'm going left 4 units. Do I go up or down? No, because there's a +0 sitting outside of the parentheses. So I'm not going up or down at all. My vertex is at -4, 0. So I'm going to plot that on my x-axis right there. -4, 0 is right there. AOS stands for axis of symmetry. So if I was going to draw a line down the center of the parabola, it always goes through the vertex. And a vertical line is x equals. So I'm going to write this as x equals -4, because there kind of is this imaginary vertical line that cuts through the vertex. You don't have to draw the vertical line, but that's what it's talking about. So from there, I do the parent movements. Sorry, these didn't print out great. Oh, actually, this 2 in front is doing something else, right? What's the 2 doing? It's stretching these values steeper. So you're going to double your y value. So 1, 2, 2, 8. This one won't fit, but 3, 18. So I go over 1 from the vertex and up 2, and over 2 from the vertex and up 8, twice as steep. So that parabola is twice as steep as my normal parent function. So 1, 2, and 2, 8. 2 away from the vertex is what I'm saying. 2 away from the vertex, I'm up 8. So there's a lot going into that one problem, right? All 8 of your transformation rules plus the parent function of the parabola. All right, what about the next one? Am I going left or right in this next example? Yeah, this +3 goes left 3 units. Am I going up or down? I'm going down this time 5. So let's see, let's write that. -3, -5. Right? Left 3, down 5. So I can plot where that is. Left 3 and down 5. Here's my vertex. And my axis of symmetry, x equals -3, because it's a vertical line through that vertex point. What's my a value this time? So there's an imaginary little 1 sitting there in front of that parenthesis. So it's just this parent set of moves from the vertex. 1, 1, 2, 4, 3, 9. So from the vertex, I could go over 1 and up 1, over 2 and up 1, 2, 3, 4, and over 1, 2, 3, and up 9. So that's 5, 6, 7, 8, 9. I'd be at 4, and then symmetrically over here at 4. Good morning. So that one should look less steep than the one before it, right? Compare the two with your eye. Less steep. Oh, thank you so much. Great. Leaving it in the classroom though, but I don't have a charger. Oh, okay. And this is the first class that they have, block 2? Yeah, perfect. Great, thank you so much. Yep. And then, are they going to leave it here at the end of the day without the goals? They're going to leave it somewhere in school. Okay, great. Yeah, thanks. I didn't understand that if they were going to have one in every single classroom or what. Okay. That's great. Thank you. Great. That way it doesn't have to go to and from. Yeah, that's great. Thank you so much. All right. Let's look at these other two, and then I want you to try a couple on your own. So let's see. Number 3. What's the only thing that's different about number 3? Half. So it's going to be half as steep. Where does the vertex go? Still at 0, 0. I haven't moved it left or right or up or down, right? So I'm not going to move left, right, or up, down. I'm going to keep my vertex right at 0, 0. And this one was hard enough because a fraction is a little bit more challenging, but all you're doing is cutting the height in half each time. So half of 1 is a half, half of 4 is 2, and half of 9 is 4 and a half. So we're still going over. You always go over the same x value. You don't mess with your x value. It's only changing the height of the graph. And I think that's what students sometimes try to do. Axis of symmetry at 0. So I go over 1 and up a half. I should have made this bigger. I'm going to make a note to myself that I need to change page 209 resource to have bigger graphs. Sorry, you guys are my guinea pigs. Clearly this is not big enough. So let's see, over 2 up 2, and over 3 up 4 and a half. If I wanted to, I could actually go, let's see, 4, 16 would change to 4, 8, right? So if you wanted to, you could go over 4 and up 8 and fit an additional point on your graph. So that one is half as steep. So you can compare, these axes are all the same exact size. Steeper, this is the parent function, and this one is less steep. So those three have a different, it's not a slope, it's a steepness, because a curve doesn't have a slope. All right, last one together, and then you're going to try a few practice on your own. I've got 2 transformations. I've got to flip upside down, and then what does this plus 3 do over here? So I'm not moving left or right, but I am moving up 3 units. So that puts my vertex at 0, 3. And my axis of symmetry is still at x equals 0. So 0, 3, and then I'm going to flip the parent function, this one, upside down. So over 1 and down 1, over 2, down 4, over 3, down 9. So you're going to keep practicing those, basically those moves. Over 1, down 1, over 2, down 4 on each side, over 3, down 9. Let's see. I'm at 3, so that would put me down at -6, right? I like that it's symmetrical, because if you plot one point, the other point is just symmetrical over that axis of symmetry. So that's called concave down versus concave up. Here's a question we're going to get to, but which of these has a minimum value? Like if you were going to look for a minimum, I guess I shouldn't say that. This does have a minimum value, right? But you can never get to the minimum value. This vertex is called a min, and this vertex is called a max. So when you're looking at projectile motion, right, the vertex is always at the highest point of that arch. And if you want to minimize cost in a business, the base of the parabola will always be that minimum cost. All right, let me see here. I'm going to skip 2 and 3 on the back, and I want you to see if you can. I think we're going to keep 2 and 3 for next class as a warm-up. Could you try to write the equations on the next page? So take a little bit of time. How can I draw that I've gone, right to? This one looks like it is steeper times 2, right? This one has been shifted down 5. So see if you can struggle through, think about the transformations, look at the examples we just did. See if you can do those 6 equations. You can use a partner if you want. It should take you a little bit of time, like, at least probably a minute per, just how you did the other ones. But number 1 is right to. So you would put x minus 2 in the parentheses and then square the parentheses to show that it's a quadratic. Number 2 hasn't been moved, but it is steeper. So 2 in front of the x squared shows that it's just a steeper graph. So here were the answers for that 209 practice. All right. So the last thing to choose. So the box method, see how I'm doing the same problem twice? I am taking this binomial, x minus 2. Binomial just means there's 2 terms. So x minus 2 is a binomial, and 2x plus 2 is also a binomial. There's 2 terms in each parenthesis. So the box method is just using kind of the idea of algebra, of area. So I have x minus 2 and 2x plus 1. It's a way that you can stay organized when you're multiplying these binomials to make sure that you don't miss one step. And we're just going to multiply. So I take 2x times x. That gives me 2x squared. And then I take this 2x times this negative 2, and I get negative 4x in the top right box. And then I take this x times 1, and I get 1x in this bottom left box, or just x. And I take negative 2 times 1, and I get negative 2. So I have 4 terms inside this area problem, but I'm going to write my answer by combining like terms. I really have 2x squared, and then I have negative 4 plus 1 x's. So I really have negative 3 x's altogether if I add them up. Right? Negative 4 apples plus 1 apple would be negative 3 apples. And then minus 2 is my constant. So it gives me an answer of that trinomial. So this is called factored form, and this is called standard form, and they're exactly equal to each other. They're just written in 2 different formats. So I don't like writing out the box. I just like kind of doing it in my head. So that's where the idea of FOIL comes in so that you don't miss a step. So first stands for multiplying x times 2x. And that's what we did first up here in the box, right? 2x squared. So x times 2x is 2x squared. Outer stands for multiplying this x times this 1. So that gives me 1x. And up here, it didn't really matter what I did, second or third. Here, I'm multiplying I for inner. So the negative 2 times the 2x is negative 4x. That gives me the same thing I got in my box. And then last stands for this negative 2 times this positive 1, which again is negative 2. It gives you the exact 4 terms that your box gave you, but you didn't have to write out the box. You did first, outer, inner, last. So whichever one, my final answer is still 2x squared minus 3x minus 2 because I can combine those like terms. So which way did you like best? I'd like you to try the next one using one of the 2 methods. So either write out FOIL, F-O-I-L, or write out the box and see if we can get to the same answer. And I'll put up the answer in a minute to make sure your resource page is correct. Flopped them. You should still get 6x squared as your first term, so 3x times 2x. And then when I do my first, if I did outer next, I would have gotten 12x. So inside my box, I would have gotten 12x. And then inner would give you positive 2x, and last would give you positive 4. So whether you did foil or box, you should still get 6x squared plus 14x plus 4 as your trinomial. Trinomial means there are 3 terms. So standard form, factored form. So a lot of vocabulary about quadratics. I'm going to turn it to the practice, and then if you didn't get a chance to copy that down, you could take a picture of mine. But could you try a few practicing these? Try 1 and 2, and then I'm going to show you how 3 and 4 are a slightly different process, and we're only going to do 1 through 6 today. I have one last thing that we're going to do before the end, but let's just do 1 through 6 on this page. For now, only do 1 and 2, because those are, so let's see if I just say the answers. Will you see if you get it right? I got 3x squared for my first term. Then I would have negative 6x plus 5x minus 10 that I need to combine with like terms in the middle. So 3x squared minus 1x, or I could just write minus x minus 10. Did we get it? Good. And if you didn't get it, maybe you'll start to pick up on, oh, I forgot a negative sign, or oh, I forgot to combine like terms, or oh, I made this negative 11 and this was a positive 5x. So see, or some people, they see the 5 and the 2 and they say like 7 in their head. So always make sure you say in your head what you're doing. 5 times negative 2 is negative 10. So let's see, this one would become 8x squared, 4x times 2x, plus 12x for the outer, plus 2x for the inner, and then plus 3 for the last. So 8x squared plus 14x plus 3. I just am lazy. I don't like to write the box. So I kind of do it in my head using foil, but that's just how I've always practiced it. If the box helps you stay organized, you do what's best for you. The reason I wanted you to pause on number 3 is because I wanted to show you what students do illegally using algebra and make sure that you don't do this. Do not distribute this squared symbol. The answer to this is not x squared plus 4 because this is a binomial squared. So it's actually x plus 2 times x plus 2 plus 5. So if you just distributed the square, you'd miss your outer plus your inner terms. So you actually want to write out, this one would be 2 times x minus 1 times x minus 1. I always do the FOIL first, or the box method first, and then do the other thing. So I'm going to do FOIL and then add 5 at the very, very end. I'm going to do FOIL on this one and then distribute the 2 at the very, very end. So see if you can do your FOIL or box method now on the binomials. So you're going to get a trinomial, then add 5 at the end to the constant. And this one, you're going to get a trinomial, distribute the 2 at the end. Does that make sense, hopefully? So here, right, I would get x squared, okay, plus 2x plus 2x would be plus 4x, right? And then plus 4, and then plus 5. Yes. So then the 5 gets only added to the constant term right here. So y equals x squared plus 4x plus 9. You just went from vertex form into standard form. So these are the exact same function, just written in a different format. For the other one, you're going to save the 2 till the very, very end. So you're going to do your x squared. And then if I do my outer plus my inner in one step, I'll have negative 1x is negative 2x's. Negative 1 times negative 1 is positive 1. So this is my trinomial. Because the 2's on the outside, I need to do the distributive property to every single thing in the parentheses. So I'm going to double the entire parenthesis. Yep, so 2x squared minus 4x and then plus 2. So to me, 3 and 4 have an additional layer of challenge. See if you can finish with 5 and 6 while I'm handing out this. Make sure before you do number 5, you write it as x minus 6, x minus 6. Don't commit that crime of distributing the squared symbol. I guarantee you there'll be one question on the PSAT where they try to get you to distribute the squared symbol, because that juicy answer of x squared plus 36 will be sitting down there to lure you in. And you have to say, no, don't commit that algebra crime, right? Don't commit the crime. Huh? They try to make you commit the mistakes, right? Same thing with inequalities, right? When you divide by a negative, you flip the sign. They're going to put one that they flipped the sign correctly and one that's incorrect to try to make you guess, which one would it be? So this one should have been x squared, and then your outer and your inner, you have negative 6x again, so negative 12x's. And then a negative times a negative is a positive 36. That would be like a no calculator question. Did you know that a negative times a negative is a positive, right? They want you to know that math fact. Okay, let's see. The other one would give you 3x squared. And then I'm going to write this out all 4 terms. So I would get 3x times 2 is 6x. And then 7 times x is 7x. And then 7 times 2 as a constant is plus 14. So 3x squared plus 13x plus 14. And if you are looking to get a little bit ahead this week, I'm only assigning 2-4 tonight, but that one is on graphing Vertex form with your up, down, left, right. But if you look ahead to 2-5 and you're sitting down tonight and you're like, let me get ahead, 2-5 is just multiplying using FOIL. So you could do 2-4 and 2-5 tonight if you wanted to get ahead, if you've got a busy week. This is just multiplying with FOIL like we did today. So 2-4 and 2-5. And then if you look ahead to 2-6, this is one we haven't done yet, graphing in standard form. So you'll have to hold off when you get to 2-6. Okay, this last